got the wrong microphone on. Nope, we're good. All right. So this is going to be a shorter class today. We're going to try to get you out by the break. We're just really going to kind of go over this lab and then kind of briefly preview the one that we're going to talk about on Monday, which is your Percent Lab 2, which is your second critical thinking lab. All right, let me zoom this in a little bit. All right. So the first part of this, for those that have already looked at it, was percent proportion. And like I said, this was the one where I messed up and I made them all percent questions. But the application is still the same. You set it up, cross multiply, and divide. All right. So anybody have any trouble with any of those? Those are about as easy as it got on this one. First answer just tough. All right. Number 6, Terry and Ricky went on a 40-mile canoe trip with their class. On the first day they traveled 16 miles. What percent of the total distance was that? So you could also use a percent proportion with that one. Or you could just set it up as a fraction and divide it. Then get the decimal, then multiply by 100. Right? Anybody have any trouble with 6? All right. 7. A hardware store had monthly sales of $72,400 and spent 8% of it on legal fees. How much was spent on legal fees? Now, you could just do a straight multiplication after you change the 8% to a 0.08, or if you wanted to use a percent proportion for this one, you could. The part, or the amount out of the base, is what's missing on this one, because the whole store, or the whole monthly sales was $72,400. So that's your whole, or your base. And you've got your percent, and then it said it spent that percent on legal fees. So that would be your part that would go above it. If you're doing a proportion, or you could just multiply it. Both ways work fine. So any trouble with number 7? All right. Number 8 is where we started getting into our formulas. We had a lot of formulas through the notes pages. So here's one that says the regular selling price of an item is $55. For a special year-end sale, the price is at a markdown of 20%. Find the discount sale price. Now, my morning class, they wanted me to show where everything went in the formula to make sure that they had it set up correctly. And I took a picture of that. I can upload it later, but you want me to go ahead and do that for you now too? All right. Fair is fair, right? Okay. All right. So, switch this. All right. So, this is number 8. And it's the discount formula. All right. So, our discount formula was in the notes. Now, since we had a whole lot of formulas, and these formulas are kind of tricky, make sure that you keep referring back to them, because that's what I do. Because I can't remember them all either. I'm only one person, you know. Okay, so the discount formula is either new cost or new price, whichever one that you want to put. And that's going to be equal to the old cost, or the old price, or the original price. You can use either of those 3 terms. They're sort of interchangeable. Minus your discount percent times the old price again. All right? So there's the formula. And the best way to deal with formulas is every time that you have a new problem where you have to use them, copy it down again. I don't expect you to memorize it, but at least if you copy it down again, you can see where all the parts are. Okay, so the regular selling price is $55. The discount is 20%. They're trying to find the discount sale price, or in other words, they're trying to find the new price. So this one is what we're looking for. So I'm just going to put an in there. All right. The old price was 55 minus, and then you're going to take the percent of 20%. Then that gets multiplied by the 55 again. Now, if we remember, when a percent is needed in calculations like this, you have to make it a decimal. So before you figure out your answer, the last thing you have to do is you've got to change this. Oops, almost wrote the wrong thing there. Change this to 0.2, and your 55. And then after that, it just becomes order of operations. You multiply, then subtract, and you'll have it. Okay. So I'll give y'all a minute to get that down. You might just be double checking it against something you already have, which that's fine too. Remember, this lab is due on Valentine's Day. Yes, I know, I'm the devil. I mean, it's not like it's Christmas we're talking about here. Now, if I had something due on Christmas, I really would be evil, because that's a week or two after the semester ends. All right, so everybody good on 8? At least setting it up. I'm trying not to give any answers out just yet because it's still active. All right, number 9. Now there was one that I did go ahead and find the answer for you, which I believe it actually was number 9, now that I said that, because this one is kind of hard. Okay, a store manager paid $124 for an item and set the selling price at $176.08. And you're trying to find the percent markup. And the reason why I carried this one all the way through, because it's probably the weirdest out of all the bunch. Okay? So we'll look at number 9 together, and we'll carry it all the way through. Okay, so markup formula. Okay, our markup formula was toward the end of our notes, right before ratios and rates. And it said that the retail price, which can also be called the new price, is equal to the cost, or original, the cost times 1 plus the percent markup. Okay. Now the reason why this one's weird is because you're finding the percent. And so like towards the end of it, it gets a little strange. But we'll walk you through it, because you're probably going to have one like this on your second and third percent lab. All right, so a store manager paid $124 for an item. So that makes the cost $124. And set the selling price at $176.08. $176.08. What was the percent markup? We'll just call that percent M. All right? So, now, we have everything except the percent markup. So that variable is what we're trying to find. We're trying to isolate it, and when you have a whole bunch of stuff going on around a variable you're trying to find, you've got to use inverse operations. You've got to work backwards to get all that stuff off of there to try to get it by itself. So the first thing we can do right off the bat is divide this whole thing by 124. So when you divide it by 124, this goes away. And then, I don't remember off the top of my head what this was. 176.08 divided by 124 is 1.42. Okay? So 1.42 is equal to 1 plus your percent markup. All right? So we're getting closer. Now, inverse operations, that percent markup is not alone. It's got a 1 being added to it. So what do we do next?
2%.
I can't really hear you guys over the air conditioner. But I'm going to hope that somebody said subtract the 1 off.
Yeah.
Somebody did? Okay, good. So you're going to subtract the 1 off. All right? And then think back to your elementary math. I know it's fresh on my brain right now because I'm having to help my 9-year-old. When you subtract decimals and whole numbers, you got to line them up. All right? So this becomes 0.42, and it's going to be equal to percent of M. All right, well, this is technically percent times M, right? So what do you multiply by 42 to get it to a percent? 100. So we're going to multiply this side by 100, and that's going to give us 42% is your percent markup.
Couldn't you just plug the answers into the formula?
You could do that.
Is that fine?
Yeah. You just got to show your work for that, though.
Okay.
Yep. So there's how you rearrange your markup formula to find what the percent markup was. It's just, it gets a little weird when you get down here towards the bottom. But yeah, if you want to do trial and error on number 9, like Emma suggested, where you take these and you're going to, plug them in and try them out, go for it. Just, make sure that you show your work. Okay? All right. I'll let y'all finish getting that copy down, and then we'll talk about number 10. I have to swap, hang on, I'm going to swap this for the recording, folks, because it was kind of blocked out. All right, number 10 says, I can just nope, of course not. What silly me, I was trying to slowly zoom it. And it's like, nope. Be able to see the grains of the ink. Okay.
Talking about two?
Not really, I've only got so much room to work with. All right, the appliance store where the Scott Family shops offers a 9% discount for paying cash. The Scott family received a discount of $50. So what was their total bill before the discount? So this is using the discount formula, except this time you're trying to find original price. Okay? So if you're going to use the discount formula, $50 goes there, and then 9% goes over there. So what was the original price? So it should be okay there. We'll see how that one goes, because I was looking at it and I think I read it wrong. And it should be okay. All right, so 11. The population of the U.S. in 2000 was roughly 280 million. Express this as the number of people per square mile. The land area of the United States is roughly 3,536,000 square miles. So this was going back to ratio and unit rate. All right? Ratios, rates, and unit rates. Since it's saying people per square mile, that means people per every 1 square mile. And it's telling you what order to set it up in by saying people per square mile. A little tip, if you forget what the order is, look at the answer choices. All those answer choices are the same, so that tells you how to set it up. So you're going to set this up as 280 million over 3,536,000. And then you're going to divide it. Now, if you got one of the scientific calculators, then it'll handle it. It'll be fine. But let's say if you didn't have one, you got an older model calculator that doesn't handle numbers this big. So you can reduce both of those by 1,000 right off the bat. And then you're dealing with smaller numbers that are still proportional. You just divided them both by the same thing, so the proportion remains the same. So just divide them, and then answer that one, and you'll be okay. Same thing on 12. It's just that 12 is asking for two different units. The national debt was 6.9 trillion at the end of 2003. Express this quantity as the number of dollars per person. Assume a U.S. population of 280 million. If you missed this one, most likely it's going to be because you didn't have enough zeros, because it says trillion. Okay? So just be very careful on that one. 13, 14, 15 determine the ratio of A to B, round as indicated. So on each one of these, it's going to be A over B. All right? It says ratio, but what it really wants is a unit rate. Because if you look at all the answer choices, they're not fractions. Okay? So treat these all like unit rates. Set them up, divide them, and then round where it tells you to round. I think on all three of them it's nearest hundredth. Okay? So any trouble with 13, 14, or 15? Everybody pretty much okay with those? Yeah, those aren't the worst. All right, 16. In a local election, 31,900 people voted. This was a decrease of 7% over the last election. How many people voted in the last election? So with this one, you can actually use the discount formula for this. All right. The way that it would work is the 31,900. That's going to act as your new price. A decrease of 7%. That's your discount. How many voted in the last election? That is your original. So just use that formula and you should be all right. Just kind of substitute the terms over there, but the operation is still the same. All right, 17. In a local election, 25,100 people voted. This was an increase of 6% over the last election. How many people voted in the last election? On this one, either the markup formula or the tax formula work. I think markup is probably your best bet on this. I'll look at it and see. Yeah, I'm pretty sure it's markup. Can't remember. It's been a really hectic day. All right, 18. The regular selling price of an item is $54. For a special year-end sale, the price is at a marked down of 20. Find the discount sale price. So that's just discount formula again over there. And you're looking for the new price. Same thing on 19. Regular selling price is $215. Year-end sale price is marked down to 20. Find the discount sale price. Then 20 is going back to the canoe trip. Alex and Juana went on a 75-mile canoe trip with their class. So you can use percent proportion on 20, or you can just do 21 out of 75, make it a decimal, and then make it a percent. All right. So I know that the lab is active right now, because I opened it Monday, I believe. Looking at some of these questions, if I change any of these questions, what I'll do is I'll let you know. I'll try to do it soon because I know some people have already attempted it. But maybe they'll be okay. I may just have the wrong answer marked on some of them, but I think I've had to update this assignment like 2 or 3 times by now because it's a nightmare trying to find good questions for it. But we'll see how it goes. Okay, so that one is due on the 14th. So you got 6 days left on that one, so no rush. All right, I went ahead and I opened the Percent Lab 2, the ShopKeep. This is another critical thinking lab, and what it deals with is it puts you in the shoes of someone that's running their own business, and you're dealing with various issues that pop up. So what I did was I made another PowerPoint like I did for the last critical thinking lab, and I already gave you access to it. If you can't see it, let me know, because sometimes things in Moodle don't take. But it's Percent and Critical Thinking Lab 2, the ShopKeep, and other uses of percents. We're not going to go through this whole thing today, okay? We're just going to kind of preview this for a second because I don't want to get pretty far into this today and then go from Wednesday to Monday and have you forget most of it and have to go through it again. So I'd much rather do it, start it fresh on Monday when we start doing the heavy stuff. But anyway, I don't know why that doesn't work.
To spite you.
Probably. Let's try it this way. Well, screw you too. All right. So, one thing that is going to be new on this second Percent Lab is percent of change. By the way, I was talking to the board, not to a person. When I said that a while ago, I just wanted to clear that out. Like I said, it's been kind of a frustrating thing. Anyway, percent change. Some places call it percent of increase, percent of decrease. And if they do that, they have 2 different formulas for it. But I just use percent change. All right? So percent change is the new value minus the old value divided by the old value times 100. And what this does is it gives you a percent of increase or decrease. The way that you tell if it's an increase or a decrease is if it is positive, it's an increase. If it's negative, it's a decrease. Now again, this PowerPoint is in the Moodle course, so if you can't see this up here, pull it up on the screen in front of you, and you can copy it down in your notes that way. Right. In the textbook, percent of change is a little bit complicated because it breaks it down into 2 different kinds, and it can get a little rough. So we're just going to use this one. So yeah, if you want to see like an expanded version of percent of change, it's in chapter 3, I believe. And it talks about relative and absolute value and things of that sort. And it gets kind of hairy. But we'll just use this one. It works fine. So times when you would use this. All right, so like let's say when we start looking at this on Monday, you get a question that says you've got an employee who made $15 an hour last year and is making $17 an hour this year. What is his percent of change in his salary? Well, you would put the 17 here because that's his new hourly wage. Put the 15 here and here. So 17 minus 15 divided by 15 times 100 will give you a positive percentage, and that's how much their salary changed. Let's say that a woman is running a store, a hardware store, and she sells 75 shovels in December, but only 20 in March. All right, and you want to find out what percent of change that was. So 75 this time is going to be your old value, and 20 is going to be your new value. So this would say 20 minus 75 over 75. Well, that's going to give you a negative percentage because you're subtracting more than you have. So that's how we do percent of increase or decrease using one formula. I figured one formula was better than two because when you have different formulas, the top values change, and I didn't want you to mix them up. Sound good? All right, that doesn't work. Okay, so here's an example that I know the 110 books loved using years ago. So a university's enrollment in January is 7,859 students. In September, the total enrollment was 8,834. What's the percent change, and is it positive or negative? So with one like this, you have to decide which one is your new value and which one is your old value. Which one is your new value? I heard it whispered. Yeah, September's your new one. Because think about the order of the months. September comes after January. So September is your new value and January is your old one. So you would do 8834 minus 7859 divided by 7859 times 100. There's your percent change. And if that is a positive percent change, it is an increase. And if it's a negative percent change, it's a decrease. But this one's just asking positive or negative. So that's not too bad. All right. So any questions about percent of change? How many of you have seen this before at one point or another? A couple of you. When we start working with it, it'll probably come back to you. I know that if you had me for 110 in recent years, you've seen this, whether you realize it or not. So, there it is again. Okay, so on Monday, when we come in, because like I said, I didn't want to start this right now and then have it leave your memory and have to, start it back over on Monday. So this exercise will put you in the shoes of a store owner, and you'll be examining situations like customers buying things at a discount, how much you'll have to mark up an item to make a profit, how to add sales tax to the retail price. And these bottom two are ones that we haven't really seen yet. A change in employee salary, we kind of talked about that with percent change. But the bottom one, how to calculate an employee's overtime. In years past, when I had the 043 class, that one got just about everybody that I saw. I said just about, not everybody. Because you have to set it up algebraically and it gets a little weird. Because sometimes it's hard to see where the percentages come from, stuff like that. But we'll work it out, don't worry about it. So I wanted to show you how many examples I've got planned out. So from slide 5, no, not 5. 5 is just vocabulary. So from slide 6 to 14. So I got about 8 examples there. We may not get to them all on Monday, but we'll do as many as we can to make sure that everybody's, got a pretty good grip of what's going on. Because percent lab tube is tough. It is. So we've got to do what we can to make sure everybody's prepared. All right. So when we come in on Monday, we'll, remind everyone to make sure that they get their homework turned in on Tuesday. Then we'll start looking at this. And we'll examine different scenarios. We'll come up with a plan. It might be a formula. All right. Now, with all of these, it should be a formula because these aren't multiple choice. Trial and error only works on multiple choice. So, all right. So, yep, quick class today. I'm going to, like I said, I'm going to go back and take a look at that percent lab 1. If I make any changes to it, I'll let you know. If I do wind up changing whole questions, I'll likely have to wipe out everybody's attempts and have you start from scratch. I don't want to do that though, so I might just make some minor tweaks. Okay? All right. Any questions? All right. Well, I will see you guys on Monday.